Welcome to the Meadow Map. This is a space where turtles cross stepping stones and natural garden plots form perfect grids. In this world, we operate on a simple rule: picture it, then measure it. Until now, you've likely focused on measuring flat areas. Today, we are pushing that logic outward to find the exact volume of three-dimensional curved solids and real containers. While natural curves might seem difficult to pin down, they follow strict geometric patterns. By recognizing the underlying shapes, like cylinders, cones, and spheres, we can calculate exactly how much physical space they occupy. Look at this vertical burrow housing a rabbit. We can model this space as a cylinder. This cylinder has a radius of 3 units and a depth, or height, of 5 units. To find the volume, we start by calculating the area of the flat circular base, using our radius of 3. That gives us a base area of pi times 3 squared. Next, imagine taking that flat circular area and stacking it upward, cell by cell, until it fills the entire height of 5. We multiply the base area by the height. 3 squared is 9, and 9 times 5 gives us a total volume of 45 pi cubic units. We leave pi as a variable to keep the answer mathematically precise. The volume of a cylinder is always the area of the circular base multiplied by the height of the shape. That is why the formula is V equals pi r squared h. Let's compare that to the conical pile of sand near this pacing fox. Notice the dimensions. This cone shares the exact same radius of 3 and height of 5 as our cylinder. Because it tapers to a single point, it takes up far less space. A cone holds exactly 1/3 the volume of a cylinder with identical dimensions. If we slice the surrounding cylinder's volume into 3 equal vertical sections, you can see that the cone fits perfectly inside exactly one of those thirds. This gives us the formula for the volume of a cone. V equals 1/3 pi r squared h. Take a moment, pause the video, and calculate the volume of this sand pile. Let's work through the steps. We know the full cylinder portion is 45 pi. Multiplying that by 1/3 gives us 15 pi cubic units. The 1/3 fraction is a permanent rule of the formula. A cone's volume is mathematically bound to the cylinder that encloses it. Finally, observe this perfectly spherical water droplet on a mossy stone. This sphere has a radius of 3 centimeters from its center to its edge. The formula for the volume of a sphere introduces a new pattern. V equals 4/3 pi r cubed. Watch the exponent closely. Unlike cylinders and cones, which use a squared radius, a sphere requires you to cube the radius. Substituting our radius of 3, we calculate the cube. 3 times 3 times 3 gives us 27. Next, we multiply 27 by the fraction 4/3. 27 divided by 3 is 9, and 9 times 4 brings us to a final volume of 36 pi cubic centimeters. A sphere uses the radius cubed because it lacks a flat 2-dimensional base. The volume measures 3-dimensional space extending outward in all directions from a single center point. With these 3 volumes mapped out above the meadow, we have to address a common trap. Often, a real-world problem will give you the full width of a shape, the diameter, instead of the radius. Before you touch any volume formula, you must do one thing: cut that diameter in half to find your radius. Once you have the radius, the formulas are clear. A cylinder is pi r squared h. A cone is exactly 1/3 of that cylinder, and a sphere is 4/3 pi r cubed. Mastering how to picture these boundaries and then calculate them pushes your measurement skills into the physical world and prepares you for high school geometry.